Now today we'll do action of ammonium hydroxide on certain salt solutions. Okay. Today we'll do action of ammonium hydroxide on certain salt solution. Now we will take salt solution and ammonium hydroxide is added to the salt solution dropwise, which result in a formation of metal hydroxide precipitate in addition to salt formed in solution. Now here some precipitated metallic hydroxides are soluble in excess of ammonium hydroxide. Because of the formation of soluble amino compounds on further reaction with excess of ammonium hydroxide. So this is very important that some of the precipitated metallic hydroxides are soluble in excess of ammonium hydroxide because of the formation of soluble amino compound on further reaction with excess of ammonium hydroxide. So here we will start with calcium salt. Here the calcium salt, no PPT formed. ठीक है ना? No PPT is formed on addition of excess ammonium hydroxide because the concentration of ammonium hydroxide ions from the ionization of ammonium hydroxide is low, and therefore it cannot precipitate the hydroxide of calcium. ठीक है ना? So in here the calcium salt, no PPT is formed because the concentration of hydroxide ions from the ionization of ammonium hydroxide is very low and it cannot precipitate the hydroxide of calcium. Second, here we will take iron. First we will take iron, second salt. Ferrous ion. Now first we will take ferrous sulfate. It is green in color. When it is reacted with ammonium hydroxide, it gives dirty green PPT of ferrous hydroxide. Dirty green PPT of ferrous hydroxide. In addition to it, colorless solution of ammonium sulfate is formed. Now this dirty green ppt of ferrous hydroxide is insoluble in excess of ammonium hydroxide. Understood? Now second we will do ferric ion. Iron, third, salts, ferric ion. We will take ferric chloride. We will take ferric chloride, yellow solution, and when ammonium hydroxide is added to it, then reddish brown ppt of ferric hydroxide is formed, which is insoluble in excess of ammonium hydroxide. In addition to it, colorless solution of ammonium chloride is formed. Now second we will take ferric sulfate. It's yellow in color. When it is reacted with ammonium hydroxide, then again we will get reddish brown ppt of ferric hydroxide, which is insoluble in excess of ammonium hydroxide. In addition to it, colorless solution of ammonium sulfate is formed. I will balance it. So here we conclude that ferrous hydroxide gives dirty green ppt and ferric hydroxide, it gives reddish brown ppt, and both of them are insoluble in excess of ammonium hydroxide. This one is ferrous hydroxide and this is ferric hydroxide. Ferrous hydroxide, it gives dirty green ppt, and ferric hydroxide, it gives reddish brown ppt, and both of them are insoluble in excess of ammonium hydroxide. Now Third, we will take lead salt. Now we will take lead nitrate. Lead nitrate is colorless. In addition to it, we will take ammonium hydroxide. Now here we will get chalky white PPT of lead hydroxide. We will get chalky white PPT of lead hydroxide. In addition to it, we will get ammonium nitrate. This chalky white PPT of lead hydroxide is insoluble in excess of ammonium hydroxide. Again, I'm repeating this. We will take lead nitrate, and when we will add ammonium hydroxide to it, the colorless lead nitrate, it precipitates into chalky white PPT of lead hydroxide, which is insoluble in excess of ammonium hydroxide. In addition to it, we get ammonium nitrate. We get ammonium nitrate. Now here we will balance the equation like this. So here we conclude that lead hydroxide, it is a chalky white PPT, insoluble in excess of ammonium hydroxide. Now we will react copper second salts with ammonium hydroxide. Now we have taken copper sulfate, which is blue, and we have added ammonium hydroxide, which results in the formation of pale blue PPT. In addition to it, ammonium sulfate is formed, which is colorless in solution. Now when excess of ammonium hydroxide is added, the PPT dissolves. Now here we have taken copper hydroxide, which is pale blue, ammonium sulfate and ammonium hydroxide. Now copper hydroxide dissolves and there is a formation of soluble tetraamine copper second sulfate. Tetraamine copper second sulfate. In addition to it, water molecules is formed. Now I will balance the equation here. Now this tetraamine copper second sulfate, it forms deep blue solution, or we can react copper hydroxide with ammonium hydroxide. Now here we will get, after reaction, tetraamine copper hydroxide. We will get tetraamine copper hydroxide plus water molecule. I will balance the equation here. Understood? Now this reaction is a characteristic property of copper ions and is used for its detection in qualitative analysis. Understood? I'm repeating again. This reaction is a characteristic property of copper ions and it is used for its detection in qualitative analysis. Now we conclude that copper hydroxide is a insoluble pale blue PPT which dissolves in excess of ammonium hydroxide, and there is a formation of soluble amino compound. This copper hydroxide is pale blue PPT. Okay, it is a pale blue PPT, insoluble pale blue PPT, dissolved in excess of ammonium hydroxide due to the formation of soluble amino compound. Now we will do another compound. Now here we will do, next is zinc salts. Now zinc sulfate, it is a colorless solution. When reacted with ammonium hydroxide, it forms white gelatinous PPT of zinc hydroxide. It forms white gelatinous PPT of zinc hydroxide. In addition to it, it forms ammonium sulfate. It is colorless in solution. Zinc sulfate, which is a colorless solution, when reacted with ammonium hydroxide, it forms white gelatinous PPT of zinc hydroxide. In addition to it, ammonium sulfate is formed, which is colorless in solution. Now I will balance the equation here. Now an excess of ammonium hydroxide is added. PPT dissolves. White gelatinous PPT of zinc hydroxide, it dissolves. Now he will see the equation. When zinc hydroxide ammonium sulfate and excess of ammonium hydroxide is added, reaction take place, and after reaction tetraamine zinc second sulfate, tetraamine zinc second sulfate solution is formed. It is a colorless solution. In addition to it, water is formed. Now we will balance it. Or we can write it like this: zinc hydroxide, and we will add excess of ammonium hydroxide. Then it will result in tetraamine zinc hydroxide. In addition to it, water is formed. Now we will balance the equation. So here we conclude that zinc hydroxide, which is a white gelatinous PPT, it dissolves in excess of ammonium hydroxide due to the formation of soluble amino compound.